What is up, Algebra 2? This is lesson 5.7, and the objective for today is apply the fundamental theorem of algebra. It's got to be a pretty big deal if it's called the fundamental theorem of algebra. So here's the fundamental theorem of algebra. Boom, the theorem says, if f of x is a polynomial of degree n, meaning the highest exponent is n power, so maybe like 5 or 10, where n is bigger than 0, then the equation f of x is equal to 0 has at least one solution in the set of complex numbers. And the corollary, and this is one that's used more than the theorem, is if f of x is a polynomial of degree n where n is bigger than 0, same start off here, then the equation f of x equals to 0 has exactly n solutions, provided each solution repeated twice is counted as 2 solutions, each solution repeated 3 times is counted as 3 solutions, and so on. So that means if n, so if it's a quadratic, that means that there's going to be 2 solutions. If it's a cubic, there's going to be 3 solutions. So it's a pretty strong theorem that says whatever the degree is of the polynomial, there'll be that many solutions, assuming that you count the multiplicity. And so these first two questions are pretty simple. Number one says, how many solutions does the equation this equal to 0 have? Well, notice it's a 4th degree, so that means the answer is going to be 4. How many zeros does the function this have? Well, this is a cubic, so the answer is going to be 3. So now this one says find all the zeros of the polynomial function. And so because of the fundamental theorem of algebra, we know that there are going to be 3 roots, right? And from the previous lesson, we know that there's going to be the rational ones is going to be plus or minus 1, plus or minus 3, or plus or minus 9, because my constant term is 9, which only has factors of 1, 3, and 9. My leading coefficient is 1. So it's going to be 1 over 1, 3 over 1, and 9 over 1. And the plus or minus of those. So one of those 6 solutions. So I'm going to see if I can find one of those. So I'm just going to start with 1, because that seems like a nice, easy thing to do. So bring down the 1. 1 times 1 is 1. 7 plus 1 is 8. That's going to be 8. That's going to give me 23. 23, not 0. So then let's try with negative 1. So it's going to be 1. 1 times negative 1 is negative 1. That's going to give me 6. Negative 6. That's going to give me 9. Negative 1 times 9 is going to give me negative 9. And that does come out to be 0. So then I can rewrite this polynomial as this one. X plus 1 times x squared plus 6x plus 9. I can do that because this 9 is right here, this 6 is right here is a coefficient of here, and then I have this factor, remember it's the opposite of this one, so it's x plus 1 because we had a minus 1 up here. So if I plug minus 1 in here, that'd make that 0. So this is now factored into this. And then since we're trying to find all the zeros, let's go ahead and try to factor this right-hand side a little more. Factors of 9 that add up to 6. So it's going to be 3 and 3. So x plus 3, x plus 3. So then, if all this is equal to 0, I have either x plus 1 is equal to 0, x plus 3 is equal to 0, or x plus 3 is equal to 0. Solving this is going to be x is equal to negative 1, x equals negative 3, or x equals negative 3. Notice these two are the same, but we do have 3 solutions, just one of them is repeated. So my solution set is going to be negative 3 and negative 1. Those are all the zeros of the function. Just this one here has a multiplicity of 2. giving me all 3 that we talked about earlier. All right, now this is the complex conjugate theorem. Remember a complex conjugate? If you had like 2 plus 3i, remember the complex conjugate of that is 2 minus 3i, just changing the sign of the imaginary part. And this theorem says, if f is a polynomial function with real coefficients, meaning that like the numbers in front of the variables are real numbers, and a plus bi is an imaginary 0 of f, meaning it's one of the solutions, a plus bi, then a minus bi is also a 0 of the function. So if one complex number is a solution, then the complex conjugate is also a solution. So if you find one of them to be, then you know the other one is as well. And the same thing goes for irrational numbers. Pretty much the same thing. If you have something a plus b square root of b, then also a minus the square root of b is also going to be a 0. So the irrational conjugate is also a solution. So this is actually something pretty fun. It says write a polynomial function, f of x, of least degree, so you want to keep it as low a degree as possible, that has rational coefficients, so just don't get crazy with those, a leading coefficient of 1, and the given zeros. So pretty much what this means, we're going to do this one here on the left, number 5 first. It says if negative 1 is a solution, that means x plus 1 is going to be one of the factors, because if I plugged negative 1 into that, that would come out to be 0. If 2 is a solution, that means x minus 2 is going to be a factor of that. And if 4 is a 0, then that means x minus 4 is going to be a 0. So if I plugged negative 1 in here, this whole thing would come out to be 0. If I plug 2 into this whole thing would come out to be 0. If I plug 4 into this whole thing would be 0. So then, all we need to do now is expand this. So I'm going to multiply these two first. So first, x times x is x squared. It's going to be minus, this is going to be minus 4x, minus 2 more, so it's going to be minus 6x, and then plus 8. And then I'm going to multiply it by that x plus 1. So this times this is going to give me x cubed. This times this, minus 6x squared. This times this, plus 8x. This times this, plus x squared. This times this, minus 6x, and then plus 8. I'm going to do this times this. So that means my f of x is going to equal to x cubed minus 5x squared, because those two together combines to give me negative 5x. These two give me plus 2x plus 8.